Hello everyone, welcome to Maths Wheels. In this session, we shall learn about relationship between zeros and coefficient of polynomials. In this, we will be dealing with quadratic polynomials and cubic polynomials. This is part 3 of polynomial chapter. So if you have missed any earlier videos, then please do watch those so that you will have continuity of the chapter. So now, let's get started. Now, before we jump on to the quadratic and cubic polynomials, let's first try to understand what is the relation between zeros and coefficient of linear polynomial. So let's first talk about linear polynomial. Now, we learned that the standard or the general form of linear polynomial is ax plus b, where a is coefficient and b is constant. What is the zero of this linear polynomial? It is minus b by a, which we can write as minus of constant divided by coefficient of x, since b is the constant and a is the coefficient. Here, if you see this relation, we can clearly see there is a relation between 0 and the coefficient of x. So this is about linear polynomial. Now let's talk about quadratic. Let's take an example of quadratic polynomial. Now, we know how to factorize this polynomial. By factorizing it, we get the zeros of the polynomial. Now, to factorize it, we split the middle term, that is 5, in such a way that the two numbers, when added, we get addition as 5. And when the two numbers are multiplied, we get the product of coefficient and the constant. That is, in this example, we have coefficient as 3 and constant as minus 2. So we should get minus of 6 as the product. In simple words, we can say we need to split middle term 5 in such a way that addition of the numbers should be 5 and the multiplication of these numbers should be minus 6. Now just think, what can be those numbers? It can be 6 and minus 1. So if you add 6 and minus 1, you get 5. And if you multiply 6 and minus 1, you get minus of 6. Now, if you compare this example with the general form of quadratic polynomial, it is ax square plus bx plus c. What will be the values of a, b and c here? A is 3, b is 5 and c is minus of 2. Okay. Now, after splitting the middle term, we have got two values, 6 and minus 1 for this example, right? So let's put this in our example. In the polynomial, what we get? 3x square plus 6x minus x minus 2. This minus x is nothing but minus 1 of x. So we got these two values, 6 and minus 1. Now, if you take 3x common from this term, you get what is left out? X plus 2. And if you take minus 1 common here, what you get? X plus 2. So we took minus 1 common from this term. Again, from this, we can take x plus 2 as common. So what we get? We took x plus 2 common. What is left out? 3x minus 1. And to find the zeros, we need to equate each of these terms to 0. So what will be the equation here? X plus 2 equals to 0 and 3x minus 1 equals to 0. So what is the value of x we get here? It is x equals to minus 2 and here x equals to 1 by 3. Now what happens if we add these zeros we got here? Get sum of zeros equals to minus 2 plus 1 by 3, which is nothing but minus 6 plus 1 divided by 3, which is equals to minus 5 by 3. Now similarly, let's find product of zeros. We get minus 2 into 1 by 3. So it is minus 2 divided by 3. If you compare these values, the values we got from the general form of the quadratic polynomial, we can see minus 5 is, this 5 is a value of b. So we can write this as minus of b divided by this 3 is the value of a. So we can write this as a. So it will be minus b by a. And what is b here? It is coefficient of x. And what is a here? It is coefficient of x square. Similarly, in the product of zeros, this 2 is value of c, minus 2 is the value of c, so we can write this as c, divided by this 3 is a value of a, so we can write it as c divided by a. This is c is the constant, c is coefficient of x square. What is the sum of zeros we got? It is minus of coefficient of x divided by minus of coefficient of x square. And we can clearly see there is a relation between sum of zeros and coefficient. Similarly, if you look at the product of zeros, what we got? It is constant divided by coefficient of x square. You can clearly see there is a relation between product of zeros and the coefficient. Okay. To generalize this, if alpha and beta zeros of this quadratic polynomial x square plus bx plus c, if you compare it with the example we have seen, the product of two terms x plus 2 and ax minus 1. From these two terms we have got the zeros of polynomials, right? So we can write this standard form quadratic polynomial as minus alpha x minus beta, the product of these two terms x minus alpha and x minus beta, and there can be a constant k. Is what we get k minus alpha x plus beta x plus alpha beta. All this what we get, and if we take x is common here, dot alpha plus beta. If you observe this last expression, it is alpha plus beta, it is the sum of 0. This last term alpha beta, this is the product of 0. This is the final expression we get here, ax square plus bx plus c is to k of minus 2 sum of zeros plus product of zeros. So whenever alpha and beta are given, calculate the quadratic polynomial using this. So this is the general formula to calculate quadratic polynomial from the zeros given. Now we have already seen sum of zeros and product of zeros. So we can express this as sum of zeros as alpha plus beta, and what value we got? Minus b by a, and product of zeros we can indicate this as alpha into beta is c by a. So these are the only things we need to remember, this main formula and sum of zeros and the product of zeros. Now there can be two types of questions asked based on the concept we learned. Let's take the first question. Find the zeros of quadratic polynomial x square plus 7x plus 10 and verify the relationship between zeros and coefficients. How to solve this? First step is to find zeros of this polynomial. Let's first find a, b and c for this. So if you compare it in this general form, ax square plus bx plus c, what is a here? It is 1. What is b here? It is 7. And what is c here? It is 10. What is the product of a and c? It is 10. Now what is the middle term we have? 7. So we need to split this 10 into the two numbers in such a way that we should get product as 10 and the addition as 7. What can be those two numbers? 5 and 2. So if you multiply this, you get 10, and if you add 5 and 7, you get 7. So let's put these values in the polynomial. What we get? X square plus 5x plus 2x plus 10. Now from these terms you can take x common. What is left out? X plus 5. And from these terms you can take 2 common. What is left out? X plus 5. Now from this whole term you can take x plus 5 as common. So what is left out? X plus 2. Now to find the 0, we equate each of these to 0. So what we get? X plus 5 equals to 0 and x plus 2 equals to 0. So what are the values of x we get? X equals to minus 5 and x equals to minus 2. So these are the zeros of this quadratic polynomial. Now the question is, we have to verify the relationship between zeros and coefficients. How to find it? Now we already learned that sum of zeros is equals to minus b by a. That is, b is coefficient of x divided by coefficient of x squared. And also we learned that product of zeros is equals to c by a. That is, constant divided by coefficient of x squared. Now, to verify the relationship between zeros and coefficients, we need to verify whether these conditions hold good for our polynomial. So let's verify this. What is the sum of zeros for the given polynomial? It is minus 5 plus minus 2, which is nothing but minus 7. And we can write this minus 7 as minus 7 by 1. Now, if you observe what is 7, it is the value of b, and what is 1, it is the value of a. So we can write this as b divided by a, and minus sign will be there as it is. So now we have verified that sum of zeros is minus b by a. So we have verified it. Sum of zeros is correct. Now let's verify the product of zeros. For the given polynomial, it is minus 5 into minus 2. What we get? It is equals to 10, and we can write this 10 as 10 divided by 1. What is 10? It is the value of c, and what is 1? It is the value of a. So now we have verified the product of zeros is c by a. In this way, we have verified the relationship between zeros and coefficients. Now let's move on to the second type of question. Next type of question is, find the quadratic equation whose zeros are 2 and minus 1 by 3. Let's take alpha as 2 and beta as minus 1 by 3. Now what is the sum of zeros? That is alpha plus beta equals to 2 plus minus 1 by 3. So if you calculate this, you will get by 3. Similarly, find product of alpha and beta, that is alpha beta is 2 into minus 1 by 3, that is minus 2 by 3. We have got alpha plus beta equals to 5 by 3 and alpha beta as minus 2 by 3. Now we learn the general formula to calculate the quadratic equation if alpha and beta are given. What is that formula? ax square bx c equals to k into x square minus x alpha plus beta plus alpha beta. Now we know the values of alpha plus beta and alpha beta, right? So let's put that in this equation. We get k into x square minus x. What is alpha plus beta? It is 5 by 3, and alpha beta is minus 2 by 3. Solving this, you get x square minus 5x by 3 minus 2 by 3. Again solve this, you get, if LCM is 3, get 3x square minus 5x minus 2. Now if this k is 3, what we get? 3 into 3x square minus 5x minus 2 divided by 3. and this 3 gets cancelled. Final quadratic polynomial we get is 3x squared minus 5x minus 2. So this is the quadratic polynomial whose zeros are 2 and minus 1 by 3. We just need to remember this formula and find the quadratic equation. Now let's verify what is the relationship between zeros and coefficients of cubic polynomial. We learned the general form of cubic polynomial. It is ax cubed plus bx squared plus cx plus d. And we know the highest power of the variable in cubic polynomial is 3. That means a cubic polynomial can have maximum of 3 number of zeros. In this case, let's say alpha, beta and gamma are the 3 zeros of this cubic polynomial. You will find that sum of zeros, that is alpha plus beta plus gamma, equals to minus of coefficient of x square divided by coefficient of x cube. Similarly, product of zeros, that is alpha, beta, gamma, you will find it is equals to minus of constant divided by coefficient of x cube. And now since there are 3 zeros of polynomial, you will find one more relation, that is sum of product of 2 zeros taken at a time. That is, if we take alpha beta, beta gamma plus alpha gamma, means we are taking 2 zeros, product of 2 zeros, and we are taking the sum of those, will be minus of coefficient of x divided by coefficient of x cube. We will be taking the question based on this concept while doing the exercise. Let us summarize what we learned so far for a quadratic polynomial and for a cubic polynomial. We have roots for the zeros here, the sum of zeros, the product of zeros, and the sum of product of zeros. For the quadratic polynomial x squared plus bx plus c, we have 2 zeros, alpha and beta. For a cubic polynomial ax cubed plus bx squared plus cx plus d, we have 3 zeros, alpha, beta and gamma. For a quadratic polynomial, what is the sum of zeros? Alpha plus beta equals to minus of coefficient of x divided by coefficient of x squared. So whichever is the highest power, we write it in the denominator. So we have coefficient of x squared. Okay. And in the numerator, we write coefficient of second term. Let's write the sum of zeros for cubic polynomial. It is alpha plus beta plus gamma equals to minus of, what is the second term here? It is bx squared. So let's write coefficient of x squared. So this is the numerator. What is the denominator? Coefficient of highest power. Coefficient of highest power is 3 here. 8x cube, right? So it is coefficient of x cube in the denominator. Now what is the product of zeros for quadratic polynomial? It is alpha beta equals to constant divided by coefficient of x squared. Similarly, for cubic polynomial, it is alpha, beta, gamma, constant divided by minus of constant divided by coefficient of x cube. So, if you observe whether it is the sum or the product, denominator here is same. Same is the case for quadratic polynomial. Denominator is same. Now, let's write the sum of product of zeros for cubic polynomial. We don't have relation for quadratic polynomial. Let's write it for cubic. It is alpha beta, beta gamma plus alpha gamma equals to coefficient of x divided by coefficient of x cube. So here in this case also the denominator will be the same. These are all important formulas that you should remember